In this video, we're going to look at simplifying radicals. This is something new to most of you, and I know it's a little bit tricky, but this, like almost everything we've done so far, just takes practice. So you can't really expect to be good at it until you've done it quite a few times. I want to clarify what I mean by simplifying radicals. I'm going to do a quick walkthrough for one problem without an explanation, just to show you what end result we're looking for here. So I'm going to separate this 12 into 4 and 3. So this is going to be my final answer for the square root of 12, plus or minus 2 times the square root of 3. What I'm not going to do is just put the square root of 12 into the calculator and get a decimal. When we have our final answer, we're only going to have an integer, possibly the letter I, and then maybe something under the radical. We will not have decimals. So I'm going to go over a couple things that we need to remember as we go through these problems. The square root of x squared is x. The square root of -1 equals the imaginary number I. Some of you are wanting to use -1 as a square root of -1. But let's look at how that doesn't work. In order for something to be square root, you have to be able to multiply it by itself and to get the value that you're looking for. In this case, we have two negatives, and a negative times a negative is going to be a positive. So -1 is a square root of +1. And this property of negative numbers means that you cannot take the square root of a negative number. So that's no good. We went over this property in our notes during class, but this is something that you're going to have to see over and over again to really figure it out. It's just something that takes practice. If you multiply two things together underneath a radical, you can separate these two things and give them their own radical. The point of teaching you this property is to give you a step towards factoring out perfect squares. Let's say we have 4 times 2 underneath the radical. This is just saying that we can separate the 4 and the 2 and put them under their own radicals and multiply them times each other. And the last thing that we're going to go over here is that when we take the square root of something like 4, we now have two possible solutions. When you were first introduced to square roots, you would have learned that the square root of 4 is 2. Now that you're in Algebra 2, the square root of 4 is positive or -2. This little sign up here, when we say positive or -2, what we mean is that the answer can either be +2 or it can be -2. So there are two different possibilities. Adding this little plus minus is just a shortcut to say that. So let's get into the steps to solving these problems. I'm going to start with one from the homework. For step 1, if the number under the radical is negative, we start by factoring out a -1. We're going to use that AB property for this. I'm going to start by factoring out a -1 from -12 and turning this into -1 times 12. And then I'm going to use the AB property of radicals and separate that into -1 and 12. For my second step, I'm going to look for a perfect square to factor out. And when I say perfect square, I mean 4, 9, 16, 25, etc. You may recognize these as being 2 squared, 3 squared, 4 squared, etc. Perfect square is just a number that you can take the square root of and get a whole number. In this case, looking at the steps that we've already done, we now have a 12 here, and we can factor one of these perfect squares out of a 12, and that would be 4. So for my next step, I'm going to leave the square root of -1 as it is for now, but I'm going to factor out a 4 from this 12. I now have 4 times 3 under the radical, which I'll further simplify to the square root of 4 times the square root of 3. And for our final step, I'm going to take this and I'm going to convert it into our final answer. I'll convert the -1 into an I. The square root of 4 will become plus or minus 2, and then the square root of 3 can't be simplified any further. And I'm going to write the 2 first, and then the I, and then the square root of 3. And that's our final answer.